Hello friends, this is another lecture of inverse Laplace transformation. In today's lecture, we will study first shifting theorem and second shifting theorem. What is first shifting theorem? If inverse Laplace of fs equals to ft, then inverse Laplace of fs plus a is equals to e raised to power minus at ft. And the second shifting theorem, if inverse Laplace of fs equals to ft, then inverse Laplace of e raised to power minus a is fs equals to ft minus a ut minus a. For the understanding, we are solving some problem based on this particular phenomena. So first question is find inverse Laplace transformation of 1 upon s plus 4 power 7. So this question is written in this particular form fs plus a. So from here first we have to identify fs. So how to identify fs? If we remove a, then what is remaining? fs. So if we remove 4, then what do we get? fs is equals to 1 upon s raised to power 7. So first we have to identify inverse Laplace of 1 upon s raised to power 7, and this can be written from inverse Laplace of 1 upon s raised to power n, which is equals to t raised to power n minus 1 upon n minus 1 factorial. So what is the value of s raised to power 7? T raised to power 7 minus 1 upon 7 minus 1 factorial. That is, it is equals to t raised to power 6 upon 6 factorial. So from first shifting theorem, inverse Laplace of 1 upon s plus 7, s plus 4 power 7 is equals to, we have to convert it into e raised to power minus at ft. So what is a? A is 4. So e raised to power minus 4t into this is ft. So e raised to power minus 4t, t raised to power 6 upon 6 factorial. Moving on to the next question. Find I.L.T of inverse Laplace transformation of s upon s square plus 6s plus 40. So for this, first we have to identify fs, but from this we cannot identify fs directly. So for the identification of fs, we have to rewrite it as fs is equals to s upon s square plus 6x plus 36 plus 4. Now this is s upon s plus 6 square plus 2 square, or now we can write it as x plus 6 minus 6. So fs can be in the form of s plus 6 upon s plus 6 square plus 2 square minus 6 upon s plus 6 square plus 2 square. Now we have two parts of this particular function. So let f1s is equals to s plus 6 upon s plus 6 square plus 2 square, and f2s is equals to 6 upon s plus 6 square plus 2 square. So first we have to identify inverse Laplace of f1. This is f1 s plus a, and this is f2 s plus a. So inverse Laplace of f1s. So f1s is, what is f1s? If we remove 6, then we get f1s, that is s upon s square plus 2 square, and it is equals to cos 2t. Same as inverse Laplace of f2s, which is equals to inverse Laplace of 6 upon s square plus 2 square, or 1 upon s square plus 2 square, which is equals to 1 upon 2 sin 2t. So from first shifting theorem, inverse Laplace of s plus 6 upon s plus 6 square plus 2 square. So here a is equals to 6. So e raised to power minus 6t into ft, and the ft is cos 2t. And for the second condition, inverse Laplace of 6 upon s plus 6 square plus 2 square is equals to, here a is also 6. So 6 into e raised to power minus 60 into 1 upon 2 sin 2t, or we can rewrite it as 3 e raised to power minus 60 sin 2t. So inverse Laplace of s upon s square plus 6s plus 40 is equals to e raised to power minus 60 cos 2t minus 3 e raised to power minus 60 sin 2t, or we can rewrite it as e raised to power minus 60 cos 2t minus thrice sin 2t. So this is question number 3. Find inverse Laplace transformation of e raised to power minus s upon s plus 2 cube. So this is in the form of e raised to power minus as into fs. That is, this is the problem of second shifting theorem. So for this we have to identify fs. So what is fs? 1 upon s plus 2 cube. So first we have to find the inverse Laplace of this particular condition. So for this is in the form of fs plus a. So first we have to apply first shifting theorem, then apply second shifting theorem. So inverse Laplace of 1 upon s cube can be found by this particular formula, that is t square upon 2 factorial, or we can write it as 1 upon 2 t square. So from first shifting theorem, inverse Laplace of 1 upon s plus 2 cube is equals to, what is a is 2, so e raised to power minus 2t into 1 upon 2 t square, that is inverse Laplace of 1 upon s plus 2 cube is equals to 1 upon 2 t square e raised to power minus 2t. Now we have to find the value of e raised to power minus s upon s plus 2 cube. So applying second shifting theorem, inverse Laplace of e raised to power minus s into 1 upon s plus 2 cube. So in this particular condition, for this a is equals to, on comparing e raised to power minus as to e raised to power minus s, we get a equals to 1. So we can write it as f t minus a u t minus a, that is we have to put, what is this? This is ft. So from the, in this particular condition we have to replace t by t minus a, and a is 1, so we have to replace t by t plus 1, that is put a t equals to t plus 1. So 1 upon 2 t plus 1 square e raised to power minus twice t plus 1 into u t plus 1. So this is the required solution of this kind of problem. Hope you understand the concept of first shifting and second shifting theorem. If you like this lecture, then like and subscribe my channel. Thank you.